Today we're going to talk about angles and circles. We need to have these notes that the sub gave you, but you also need to have your angle and circle formula sheet that we did last time. Last time we talked about central angles where it's formed by two radii and the angle equals the arc. But now we're going to look at the question, where is the vertex? And the vertex is going to move around the circle, and based on where the vertex is, we're going to decide what the formula is. So let's practice that. The first type of angle we've got is an inscribed angle. An inscribed angle is an angle formed by two chords with its vertex on the circle. So if I look at a circle, the vertex is on the actual circle, and it's formed by two chords. So there's the angle, and this right here is what we're going to call the intercepted arc. Oops, on an extra line. And so when we draw, or when we identify the intercepted arc, it's where the chords reach out and grab part of the circle, and the part of the circle that it grabs is that intercepted arc. So before we talk about the formula, let's look at a picture where we got lots of inscribed angles, and we're going to identify the angle and the intercepted arc. So first, let's look at this right here. If I look at angle EBD, just remember, B has to go in the middle because it's the vertex. Angle EBD, it's got the vertex on the circle, and it's formed by two chords, so it's definitely an inscribed angle. And when I look over here, its intercepted arc would be arc BC. All right, let's see if we find another one. What about over here? Got the vertex on the circle, formed by two chords, so this blue angle would be angle, remember C has to be in the middle because it's the vertex, so ACD, or if you said DCA, it's the same thing, and its intercepted arc would be this whole blue arc, arc AD, because when the chords reach out and grabs the arc, that's the arc it grabs. Finally, we got one more intercepted arc in the circle. If I look at this vertex right here, and these chords, then that forms an intercepted arc, and that, or excuse me, inscribed angle, and that angle would be angle BDC, and its intercepted arc would be arc BC. Okay, so we should be feeling comfortable with the angles and the arc. So flip to your formula sheet and go down here. We're only going to look at the picture at the left right now. So the picture on the left, the vertex is right here on the circle, and it's formed by two chords. Okay? And we now know that when it's formed by two chords, it's called an inscribed angle. Okay? And in this case, we have our angle and we have our arc. And when it's on the circle, the angle is 1/2 of the intercepted arc. Alright, now that we know the formula, go back, and we'll come back to the sheet in a minute. Go back to our notes, and let's practice. Now, I'm going to write out full equations right now, which is going to seem silly because it's going to be so quick, but later on it's going to help us if you force yourself to write the equation from the start. So right here, the vertex is on the circle. It's formed by two chords, so that's an inscribed angle. So the angle, which is 40, the angle is always going to be next to the vertex, equals 1/2 of the intercepted arc. So 1/2 of this arc here that we don't know. Well, I can't take half of 1x, so I'm going to multiply both sides by 2. They cancel out, so I get 80 equals x. So that's what my arc equals. Over here, they want angle ABC, this angle right here. Vertex is on the circle, formed by two chords. It must be inscribed, so this angle is 1/2 of the intercepted arc, and the intercepted arc is 150, so half of 150 is 75. Now I know you're saying I can do that in my head, and you can, and you should be able to, but I want you to start writing the formulas at the beginning so it helps you later on. Alright, let's look at this one. They want angle MNO. Well, the vertex is on the circle. It's formed by two chords, so it's going to be 1/2 of its intercepted arc. Well, it didn't give us an intercepted arc, but we know it. This is a diameter, MO is, so this arc has to be 180. So it's 1/2 of 180, so that's 90. So anytime you have an inscribed angle where the intercepted arc is a semicircle, then it's going to measure 90 degrees. All right, let's look at this picture over here. Example 5. First they want angle ACB. So let's find that. ACB. It's inscribed, so it's going to be half of its intercepted arc. So it's going to be half of 60, which would be 30. All right, let's try another one. ADB. So A to D to B. This red one, it's going to be half of its intercepted arc. So it's going to be half of 60, which would be 30. All right, one more. AEB. AEB, that's this blue arc, or excuse me, angle. So it's going to be half of its intercepted arc. So it's going to be half of 60, which is 30. Now, if you notice, all three of these angles had the same intercepted arc. And when they have the same intercepted arc, they're going to have the same measure, which is the next theorem. So if two inscribed angles have the same intercepted arc, then they are equal. So if I look here, angle ABD has this intercepted arc, and angle ACB has this intercepted arc. So since they have the same intercepted arc, we can say that angle, oops, not A, just kidding, angle B, and I can use one letter because there's only one angle coming from that vertex. Angle B is congruent to angle C. All right, let's try using that in a problem. So we look at this. Well, this angle here, vertex is on the circle formed by two chords, so this angle is half of this intercepted arc. This angle here, the vertex is on the circle, so it's half of this intercepted arc. Well, since they're half of the same arc, then we know they've got to be half of the same number, which makes them equal. So 1/3 x plus 7 has to equal x, minus 8. Okay, I'm going to clear the fractions because I think it's just a good idea. So that gives me 3 divided by 3 is 1 times 1 is 1x plus 21 equals, just getting 3x minus 24. So it gives me 2x equals 45. Don't stress about the decimal. X equals 22.5. Alright. An inscribed polygon. An inscribed polygon is a polygon with sides that are chords and the vertices on the circle. So it's completely contained in the circle. All the vertices are here on the circle, and all the sides are chords. So that's what it means to be inscribed. Okay, so now that we know inscribed, okay, let's talk about a quadrilateral being inscribed. And quadrilateral is 4 sides. So it's inscribed because all the vertices are on the circle, and all the sides are chords. So it's an inscribed quadrilateral. Okay, and when that happens, the opposite angles are supplementary. So in this picture, the measure of angle A plus the measure of angle C is going to equal 180. Likewise, the measure of angle B plus the measure of angle D is going to equal 180. Alright, so let's do some examples. Example 1. The opposite angles are going to add to 180. That means these two add to 180. So 80 plus 4x equals 180. So 4x equals 100. So x is 25. Likewise, these two angles, they're going to add to 180. So 120 plus 10y equals 180. So we get 10y equals 160. So y is 16. Okay, I want you to pause the video and do example 2 on your own. Hopefully you got x is 49 and y is 6. Now you're ready for part 2 of angles and circles.